Have you ever opened an image that just looked dull or flat? Maybe the brightness was okay, but the contrast not so much. In Matlab, there is a super useful function called imadjust, and in this video we are going to break it down. So now let's learn how to enhance contrast automatically or manually. And even you can work this contrast enhancement with color image also. So without wasting time, let's get started. So first of all, here we are going to understand what is imadjust. Imadjust is a built-in MATLAB function used to enhance the contrast in image. It works by remapping intensity values, meaning it stretches or compresses the brightness range to make the image more clearer. Now here, this is the syntax of how to use imadjust. Here, this I indicates the input image. Then this low in and high in indicates the input intensity range. And then this low out and high out. This indicates the desired output range. And finally, this J is the resulting image, which is basically the enhanced image. Now here there is one more catch, that if you miss this, MATLAB by default understand it as 0 and 1. And how it is, that I'll show you with the example. So now let's take an example to understand it better. Now this line loads a simple MATLAB image called pout.tiff. Then here we use imshow of this I. So this will show this image, and this title will show the title to that image. So now when we run this thing, you can see this original image. Now here you can observe one thing, the image is a little bit dull. So now close this thing, and now we are going to implement imadjust function on this image. Now here we have applied imadjust with no input range. We have not provided any input range and no desired output range. We have just simply used imadjust. So here MATLAB automatically finds the darkest and the brightest pixel and stretches the contrast from minimum to maximum range. Now let's run this section and you can see the difference. Now let me show you. This is the matrix over our original image I, and see here the pixel value is 107, 108, 107, right? And now let's see this value of enhanced contrast matrix, 89, 92, 89. Now let's do adjustment manually. Now here something is different. We tell the MATLAB take only the mid-range values between 0.3 and 0.7, that indicates 30% and 70%, and stretch them across to the full brightness range. This will boost the contrast mainly in mid-tone areas while ignoring extreme darker and brighter part. Now let's see this image. See this. This is mid-tone contrast. Now here let me open the K matrix, and here you can see the value 76, 79, 76, 74. Previously it was 89, 90 around, and before that in original image it was around 104 and 105. Now let me show you all these three images together so that you can better understand, right? So here we go. This is our original image. So this one is the original image, this is full contrast stretch, and this is mid-tone. So here you can clearly observe the difference in between all these three images. So now I think this makes it clear that how contrast enhancement changes the visibility in image. Now close this thing, and now we are going to take one more example. This time we'll go for color image. So here by this line we are going to load the colorful RGB image. This is the famous paper.png, right? And now we are going to apply imadjust on each color layer separately. Because for imadjust you need to have 2D matrix, right? We'll do this im.adjust separately on R, G and B plane. So here we are separating R, G and B 3 layers. Here we are considering all the cell values, but that is of only layer 1. So it is kind of a 2D matrix with all the information of layer 1 and then 2 and 3. So together they will become R, G and B, and all these three things together creates our RGB colorful image. So now what we are going to do, now we are going to combine. We have separately adjusted the contrast on each of the level, and now we are going to combine them together. And to combine them together we are going to use this cat. So we are going to combine 3 layers. Which are the 3 layers? R, G and B. This. And if you want to have a better or another example of this command, then I'll provide a video link. I have already prepared a video on this. I'll check that video and provide the link above here in I button, right? So that you can explore this function in detail. So here we have combined the adjusted channels back to full color image using this cat command. And now we are going to see this image also, but we'll see both the image side by side. So we'll subplot it, right? I am show and RGB underscore adjust. And now let's run this section. And here you can see the difference. So this is our original image and this is contrast stressed image or contrast enhanced image. So here you need to remember few things about imadjust. This imadjust function works best on grayscale or a single channel image. Don't directly apply this function to full RGB unless you split it. Here we did the same thing, right? Here we have split RGB and then we have applied imadjust. Now I'll give you a few of the practical application where you can use this function. You can use this imadjust in real world applications like enhancing medical or satellite images. You can even use it for improving scanned documents. Yes, that is really important. And then you can use in preparing image for edge detection or in machine learning process, right? So these are the applications where you can use this imadjust function. So now if you have enjoyed this particular video, then don't forget to hit the like and subscribe to this channel. And comment below if you'd like to learn something more special about image processing in Matlab, like histogram equalization or adaptive contrast. So put those things in comment section and then we'll make video on that topic also. So see you into the next video. Till that time, bye bye.